Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today, in this topic, we will study binding energy, mass defect, and the example of binding energy as well as mass defect. First, we will see what is binding energy. Before studying the concept of binding energy, first we will see the diagram of helium atom, which is composed of two protons and two neutrons. The combination of proton and neutron is known as mass number. So, in the structure of helium atom, we can say that helium nuclei is composed of two protons and two neutrons, which is also known as nucleons. In the step one, we will see that the mass of nucleus of helium atom is to be 4.001 AMU, and AMU is the unit which represent the atomic mass unit of any element. It means there are two types of masses of helium nuclei. One is experimentally determined and other mass of helium is calculated on the basis of the presence of number of protons and neutrons inside the nucleus. So there are two types of mass of nuclei of helium atom. One is known as the experimentally determined value of helium nuclei, and the other value is known as the calculated value of helium nuclei. Here is the mass of experimentally determined mass of helium nucleus, that is 4.00150 AMU, and the student you will have to memorize this value. Now we will see what is binding energy. Binding energy basically is the energy which is required to disassemble or break a whole system into separate parts. It means that if it is composed of two proton and two neutrons, then we can say that the amount of energy which is required to separate all the nucleons inside the nucleus. It means if there are two protons and two neutrons are present inside the nucleus, then we can say that the amount of energy which is required to break the proton and neutron, that energy is known as the binding energy. It means we can say that binding energy is the amount of energy which is required to break a whole system into separate parts. From the phenomena of binding energy, it is mostly related to the nucleus. So, in terms of nuclear binding energy, the nuclear binding energy is the energy that would be required to disassemble or break the nucleus of an atom into its component part, and these component part are protons and neutrons, which are collectively called as nucleons. So I have said that the amount of energy which is required to break this whole atom of nuclei into its separate protons and neutrons, that amount of energy which is required to break this nucleus into its constituent nucleons, that amount of energy is known as the binding energy. From binding energy, we can further later on discuss the phenomena of mass defect. First, I will show you some derivation in this topic, and you will have to memorize this derivation or by doing practice in your notebook. So it will be clear to all of you in from exams point of view. So first, you will have to memorize certain terms or certain points which is related to the binding energy. In your previous classes, that is first year, you have memorized that the mass of an element is expressed in terms of atomic mass unit. It means 1 AMU or atomic mass unit is written as simple AMU, and later on you will see that one atomic mass unit or 1 AMU is equal to 931 mega electron volt unit. So you will have to memorize these lines that 1 AMU is equal to 931 mega electron volt. And the other type of masses of proton and neutron, the mass of proton it come out to be 1.00728 AMU, while the mass of neutron has the value of 1.00866 AMU. from we have seen the mass of helium and nuclei, that the nucleus of helium is composed of two protons and two neutrons, and if the mass of one proton is 1.00728, and for two protons its value should be multiplied with 2, so the mass of two proton comes out to be 2.01456 AMU, while the mass of two neutron same also equal to when 2 is multiplied with one mass with one value of mass of neutron, that is 1.00866 AMU, then it comes out to be 2.01732 AMU. It means the total mass of helium nucleus will be equal to 2 proton plus 2 neutron mass, so by addition of these two value, it comes out to be 4.03188 AMU. But I have told you earlier that the mass of helium nuclei that is experimentally determined is 4.00150 AMU, while the value of helium nuclei, which is calculated on the basis of the composition of two protons and two neutrons, it comes out to be 4.03188 AMU. It means it is clear to all of you that the mass of nucleons, which is calculated, is not equal to the value of experimentally determined nucleus of helium atom. So there is a difference between the value of binding energy of the helium nuclei that is calculated, as well as the experimentally determined value. So there is a lot of difference, and this difference is known as the mass defect phenomena. Now we will see the mass defect, that the mass of an atomic nucleus is always less than the sum of the individual masses of the constituent protons and neutrons according to the Einstein equation, and this missing mass is known as the mass defect, and it represents the energy that was released when the nucleus was formed. Now I will show you this diagram on whiteboard. Here we will see some diagrams here. Uh, Now, student, I am going to draw the mass of helium nuclei, that is proton. Here is two proton present, while two neutron is present inside the nucleus. In the same way, we can say that there are uh, wait, student, I am going to draw the helium nuclei, that is your helium nuclei, right? uh, Now we can see that there are mass which we have calculated that one mass is known as the experimentally determined value. One value is known as the experimentally determined value of value of helium nuclei, and the other mass is known as the calculated mass. Other mass is known as the calculated mass. It means there are two types of masses. One is known as experimentally determined value of helium nuclei, and the other value is known as the calculated value of helium nuclei. From logical points, these two values should be equal with each other, while in this case, these values are not equal with each other. It means that there are some missing of mass of helium nuclei. It means that where the missing mass will have gone, that mass will go in term of energy. It means the missing mass, this missing mass is converted into binding energy. That energy is known as the binding energy. It means there is a loss of mass. There is a loss of some mass, loss of mass occur, and this loss of mass is known as the mass defect. It means we can say that there are two types of masses. One is known as the experimentally determined value of helium nuclei, and the other value is known as the calculated mass of helium nuclei. These two values are not equal with each other, and the calculated value is always less than the experimentally determined value. It means that the question arises that where the part of missing mass has gone out, this missing mass is converted into binding energy, which is follow the equation of Einstein, which is equal to E is equal to mc square. So the loss of mass occur here, and this loss of mass is known as the mass defect, and this mass is converted into Einstein equation, which we will see by going to our slide. As we have seen here, that the mass defect, that is small m, mass defect is always represented by delta small m, which is equal to mass of experimentally determined value of helium nuclei is minus mass of nucleons, that is the 2 proton plus 2 neutron inside the helium nuclei, which represent the calculated mass. It means the calculated mass and the experimentally determined mass when minus with each other, this difference is equal to 0.03038 AMU, and this difference is known as the mass defect. As I have told you earlier, that the mass defect of an atomic nuclei is always less than the sum of the individual masses of the constituent protons and neutrons. As we have seen here, that the mass of calculated neutron is always less that the mass of an atomic nucleus, which is experimentally determined value, is always less than the sum of the individual masses of the constituent nuclei. It means the calculated value should be greater, while the experimentally determined value is always less than the calculated value, and this will follow the Einstein equation, which is equal to mc square, and this missing mass is known as the mass defect, and it represents the energy that was released when the nucleus was formed. As we can say that when this nucleus is formed, then all these nuclei, all the protons and neutrons which are present inside the nucleus, and the amount of energy which is required to bind these nuclei, nucleons inside the nucleus, that amount of energy is known as the binding energy, and that amount of energy was released when this nucleus was formed. So we can say that there is a phenomena of mass defect which occur when the nucleons are combined inside the nucleus. So we can say that when nucleus was formed, then that amount of energy was released by the loss of the mass defect, and that amount of energy which was released is known as the binding energy. It means the amount of binding energy is known as the amount of binding energy is known as the amount of binding energy which was released that at that time is known as This missing mass is known as the binding energy, and it will represent the energy that was released when the nucleus was formed. So, in our next slide, we can say that uh, now later on we will see a further derivation of Einstein equation, that 1 AMU is always equal to 1.66 multiplied 10 raised to power minus 24 gram. It means this value is for gram, and when we will convert this gram value into kg value, then we can say that this AM value, which is equal to 1.66 multiplied 10 raised to power minus 24 gram. This gram unit is will be converted into kg. It means 1 gram always equal to 1000 kg. So 10 raised to power minus 24 will be converted into 10 raised to power minus 27 kg. As I will show you here, uh, that we can say that 1 AMU is equal to 1.66 you will discuss with me in my personal window. Now we will move back our topic, that 1 AMU is equal to this, and 1 AMU further later on will be equal to 1.66 multiplied 10 raised to power minus 27 kg. So according to the equation of Einstein, which represent that E is equal to mc square, and the m will represent the loss of mass, which we have calculated earlier, that is 0.03038 AMU. So by putting this value in Einstein equation, which is the mass defect, and we want to convert this mass in kg. So the student here, some point is missing, that it should be equal to minus 27. I have forgotten to draw the sign of minus here with this value. So you will have to put the minus sign here. So in this equation, we can say that uh, the according to equation of Einstein, the loss of mass will be equal to this. While when we want to convert this mass, atomic mass unit into kg, then you will have to multiply this loss of mass with 1.66 multiplied 10 raised to power minus 27 kg. By multiplying the velocity of light, c will represent the velocity of light here, and the value of velocity of light will be equal to 3 multiplied 10 raised to power 8 meter per second square. So by taking this square and multiplying the value of loss of mass with AMU, will be equal to 1.66 multiplied 10 raised to power minus 27 kg, and by taking square and then the value further multiplied here, the final answer will be equal to 4.533 multiplied 10 raised to power minus 12 kilogram meter square per second square. So this unit will be equal to joule. So according to this equation, we can say that it will represent the final binding energy for helium atom, which will be equal to 4.533 multiplied 10 raised to power minus 12 joule. But in term of nuclear binding energy, mostly the nuclear binding energy are usually expressed per nucleons. It means for nuclear binding energy per nucleon, there are four nucleon is present inside the helium nucleus. It means if there are four nucleon are present inside the helium nucleus, then the binding energy per nucleon always equal to 4.533 multiplied 10 raised to power minus 12 joule. That is the value of binding energy, and there are four nucleons are present. It means if there are four nucleons are present, that is two protons and two neutrons. Two proton plus two neutron always equal to four. It means by dividing the value of binding energy with the value by 4 nucleon, which represent the number of proton and neutron inside the nucleus. So we will divide the value of binding energy with 4, and it will be equal to 1.133 multiplied 10 raised to power minus 12 nucleons. So binding energy are usually expressed in unit of electron volt or million electron volt, that is mega electron volt per atom. So for get the value of mega electron volt, we will divide the value of binding energy, not divided with 4, that the value of binding energy, that is 4.533 multiplied 10 raised to power minus 12. It should be divided with the value of the charge of an electron, that is 1.6022 multiplied 10 raised to power minus 19, and by dividing these two by dividing this equation with the value of charge, then the final answer will be equal to 28.30 multiplied 10 raised to power 6 electron volt. And we know that 1 electron volt will be equal to 10 raised to power 6. So we can say that this value will be 28.30 mega electron volt. Here is the final derivation of binding energy per atom will be equal to 28.30 mega electron volt. So here is the complete derivation of helium nuclei, and there is another way to get the same value of 28 mega electron volt, that we can say that 1 AMU is equal to 931 mega electron volt. So by the entering the value of 931, that is the mass, that is 931, with the loss of mass value, as we can say that when we multiply 1 AMU equal to 931 mega electron volt, and 931 multiply the loss of mass will be equal to 28 mega electron volt. Now, student, we will study the relative stability of helium nuclei, and the other nuclei will also, that we can say that when we plot a graph between the two terms, one is known as the mass number and other term is known as the binding energy per nucleon. Mass number has been taken along x-axis while the binding energy per nucleon will be taken along y-axis. Then you can see that there are different type of nuclei which represent the different type of the values of binding energy per nucleon. We can say that the binding energy per nucleon increases rapidly with increasing mass number, uh, as we have clear from the figure, and the binding energy per nucleon value should be maximum around mass number 50, that is 9 mega electron volt, then decreases rapidly. It mean at the value of 50, we can see that at the value of 50, the value of binding energy per nucleon 8 say to above, the figure will represent here, that is 9. So we can say that the binding energy per nucleon will be increases at the mass number of about 50, and the binding energy value will be 9 mega electron volt, and then it will decreases slowly. The nuclei with highest binding energy, that is mass number 40 to 120, they are more stable. It means the element whose mass number between 40 to 120, their binding energy value will be increases. So we can say that the nuclei with highest binding energy will reside between 40 to 120, they are more stable, because so much energy would be required to separate these nuclei into their component particle. The heavier nuclei possesses low average binding energy and are therefore unstable. It means that the heavier nuclei, they have low average binding energy, and so they are therefore unstable in nature. Thus, for a heavy nuclei, it may break down, that is fission, to intermediate masses having higher average binding energies. It means that we can say that if the value of binding energy increases for any nuclei, then this heavier nuclei possesses lower average binding energy and they are unstable. It means that the element which start from this point, that is hydrogen, lithium, nitrogen, and oxygen, these elements will represent the lighter nuclei, while the element after the iron, the mass number of these elements will be increases, and they have heavier nucleus, and these heavier nucleus will be stable by emitting the radiation in by the phenomena of nuclear fission. We can say that a heavier nucleus gains stability by breakdown itself into intermediate masses of the nuclei. In another term, similarly, the higher nucleus may combine together, that is fused to form nuclei of intermediate atomic masses having high average binding energy. It means the lighter nuclei which want to gain higher value of binding energy, these nuclei should be combined with each other by the phenomena of nuclear fusion. So as a result, they gain stability. And we can conclude two main important points from here. That is, first, heavy nuclei gain stability and therefore they will release radiation if they are fragmented into two mid-sized nuclei. This process is known as fission, which occur at the right side of the graph. As we have seen here, that there is a nuclei, those nuclei which have higher atomic mass, and these elements are disintegrated by the phenomena of nuclear fission by the emission of nuclear radiation. The nuclear fission will occur at the right side of the graph. And the second postulate is that even greater amount of energy which are released in very light nuclei, they are combined or fused together to give more massive nuclei. This fusion process is the essential energy producing process in the sun, which take place on the left side of the graph. Hopefully, all of the topic will be clear and all the points are clear to all of you. And if you have any question or any query, you can ask it in comment section, or you can text me on my number. Uh, and one more important thing is that the topic of that is the relative stability of nuclei. Will You will have to prepare this topic from your given slide, not from your given notes. That is, you will have to memorize the relative stability of nucleus from here, and you can draw this graph. But this graph is almost similar as it is in your textbook, but you will have to note down the different points. That is, the relative stability of nucleus is totally different from your textbook, so you will have to note down these points. Okay, dear student, take care and Allah Hafiz.